Hi there, welcome to my channel Coding Guru, your one-stop channel for everything related to modern technologies. And this is my first video. So today we are diving deep into the world of Android, the OS that powers billions of the devices around the globe. Excited? Let's get started. So first let's get started with the history of Android. Android devices form a very essential part of huge section of mobile phones users in today's world. The global turmoil in the COVID-19 eras, the population has now entered a digital sphere. Android is most used OS in smartphones during these days of transformations. But when did something like Android take birth in the first place, and how did it decide its journey of growth? We did not know earlier that Mother Planet was to go on a social distancing strike in 2020. So, how were we all prepared? Let's answer all these questions right here. The story of Android dates back to 2003 when Andy Rubin, Rich Miner, and Nick Serres, Chris White co founded a startup called Android Inc. in Palo Alto, California. However, the company was later faced with the insufficiency of the fund, which brought Google into the picture. Google could sense a potential in this Android product carried within and sealed a deal of worth 50 million to acquire the Android in 2005. All the four co-founders soon moved to Googleplex to continue to develop the OS further under their new owners. The first Android beta version 1.0 was finally published on 5th November 2007. Okay, so this is the history of Android, how exactly it got started. Okay, so now we will look what are all the versions of Android that came into picture and what version we are using today. So first we will start with Android 1 version which started in 2008. Okay, so don't get confused here. Okay, whenever I talk about this Android 1 version, right, it is the official version. Okay, that the earlier which I was talking was beta version which was released in 5th November 2007. Okay, so up to here donut September 2009, we this is all version 1 with the minor versions like 1.1 1.2. Okay, so from here Eclair, Froyo, Gingerbread, this is Android version 2. And Honeycomb, this is version 3. Honeycomb itself is having multiple versions. Okay, then Ice Cream Sandwich, Jelly Bean, Kit Kat, this is version 4. Okay, so this is one of the major version. Like from here the Android development took a drastic change. Like this, the speed was tremendous. After this they started implementing multiple changes in their architecture and it was very speed developed. Okay, so then came Android 5 which is Lollipop, 6 which is Marshmallow, 7 Nougat, 8 is Oreo. Okay, so here this is also one of the important milestone for Android. Okay, from this they introduce something called treble architecture. Whenever if vendor or someone wants to develop their own features, they can develop it separately. So all this improvement was done in this 8 version. Then came 9 which is called Pi. Then Android 10 version which is also called Queen Start. Android 11 which is called Red Velvet. Android 12 which is also called Snow Cone, and Android 13 is called Tiramisu. 14 which is called Upside Down, and 15 Vanilla Ice Cream. So these are all the version which is currently in use today. Okay, so this is all about the different versions of Android. So now let's see what is AOSP. Now earlier we were talking about Android, we were talking about the history of Android, we know it is an open source, whoever wants they can use, but where exactly this code lies we don't know. So that is where EOSP comes into picture. EOSP is called Android Open Source Project. As its name itself tells, it is an initiative by Google to develop and maintain Android platform as open source operating system. So if you want to download the code, you can directly go to this EOSP website. You can download this EOSP source code. Okay. It provides the source code for Android OS, allowing the device manufacturers, OEMs. OEM full form is original equipment manufacturer. So Samsung, Realme, Oppo, OnePlus, these are all the OEMs. Okay, chipset vendors like Qualcomm, Nvidia. Chipset vendor is also called ODMs, original design makers, and developers. So some as Graphene OS, Lineage OS. So they are all the developers and customer Android developers. Okay, so you can customize this Android as you need it. Even we can become developer. Okay, if you want to develop something, you can develop in this Android. So why AOSP is important? So there are 3 points why AOSP is important. One is customization and flexibility. One is open source nature. Third is no Google dependency. What is this customization and flexibility? OEMs can modify and create their own versions of Android, Means if you want to create your own versions of Android, if you want to develop something, you can use this USB source code. Open source in nature. Obviously, it is an added advantage. You can download the code, you can do whatever you want, but still you have to follow the standards and you have to comply with the Google standards. Okay, make it that we have to keep in mind. Next is no Google dependency. USB can run independently of mobile of Google mobile services. Okay, so who uses USB? OEMs, chipset vendor, developer, and custom ROM creators. Who is this OEMs? OEMs are Samsung, OnePlus, and Xiaomi for custom Android version, chipset vendor, Qualcomm, MediaTek for hardware compatibility, and developers, usually custom ROM creator, like as I said, Lineage OS and Graphene OS. Okay, so when I talk about this, right, there is one common myth among us that is like Android is specifically for phones. No, you're wrong. Okay. Whenever I talk about Android, nowadays Android is getting fit into all the segments. It might be automotive segment. Qualcomm has his own Android automotive board which is compatible with Android like S8155, 8275, 775. So they are having different automotive board which uses this Android, which is mainly for Android infotainment system, and in healthcare also we use this Android. Even in TVs we use this Android. Even in watch we use this Android. So these are all the different segments where Android is getting used. Okay, that is getting used because Android is open source. Okay, so that is all about USB. Now we'll see the architecture of USB. Whenever I talk about the architecture, that is like how exactly USB is formed and what are all the different layers that is in use. So first let's get started with this, the core of Android USB, which is called Linux kernel. So you might be confused. What is this Linux kernel doing over here? We are talking about this Android OS. Why this Linux kernel comes into picture? So one thing you have to keep in mind, like whatever the OS we are using today, right? Majority every OS is using Linux itself. So every OS is developed upon Linux. Okay. Okay. Now let's see why this Linux kernel is important. So it is mainly used for memory management, process scheduling. Then it is also used for where exactly these drivers come into picture. What is this drivers? Drivers are the code which is mainly used for read, write, open, and perform multiple operations on these hardware devices. For example, you are having camera, you are having this audio mic or anything external device. So you have to have some code which will manage writing data, reading data, and opening the files. Okay, so that code is written here in this Linux kernel. So they are having some APIs. So if you want an application which will open the camera, then you have to use this driver. Okay, so for that you cannot directly access from this layer to this layer. You need some intermediate layers. Okay, so just about that there is something called HAL. So don't bother, these are not layers. Okay, system services and system services. What is this system services and daemons? These are all the background services which is running. Okay, in background user can't see these services. This is mainly used for logging the messages and for installing something. If you want to some perform some task in background like reading some file, opening some file, all these are maintained by these services. So these are basically written in C++ or C. So next layer is HAL layer, hardware abstraction layer. As the name suggests, it abstracts the underlying hardware. Hardware means it won't directly provide these hardware or driver APIs to this framework. Okay, but you have to use a standard API which is written in this hardware abstraction layer. So it acts as a bridge between your above layer and the below layer. So that is why this layer is important. Okay, so this is standard. This provides the standardized API. Whichever OEMs or the vendors use this, modify this Android, so they will be modify this part. Above this, everything is standard, which is provided by Google. The best example is now you think of two OEMs. One is Samsung and one is OnePlus. Okay, Samsung is having his own camera driver. OnePlus is having his own camera, but they can't provide different APIs to the application developers. That will be a mess, right? So for that purpose, this HAL is brought into picture. One is for providing security, one is for abstracting the APIs, one is for acting as the bridge between upper layer and the lower layer. So what happens? This will provide a standard API. Whichever vendor you go above this, the API is standard. So that is why HAL is important. Just above this HAL layer, right, there is something called as core libraries, native libraries, C++ library. Those native libraries are helper libraries for running this OS smoothly. For example, one is you want to have this display where you can see these are 3D rendering, 2D rendering. How exactly this happens? There is an external library called OpenGLES. And now you can hear my voice, right? If you are using mobile, you can hear my voice or you can see this video. So who is exactly doing that? There is something called OpenMax, okay, which is mainly used for decoding and encoding the videos. And for getting this video decoded, right? You are using that OpenMax, and there is something called a WebKit. If you are accessing any website, that WebKit is playing an important role. LibPNG, LibJPEG, all this. If you are dealing with these PNG images, JPEG images, you are using that libraries internally. So these are all third-party libraries, which is getting which is getting integrated in this native C++ layer. Okay, just about that, there is something called Android runtime. What is this Android runtime? As the name says, it provides a runtime environment for your Java application to convert this Java bytecode into the machine code. See, you might be a C++ developer, C developer. Whenever you are writing an C or C++ program, right? So you compile your program into .out files. What is this .out file? It is basically a machine code which can be understood by your hardware. So even same, see, whenever you are installing some .apks, right, applications, for example, it might be camera application, any apks. So those apks will be an intermediate code between your machine code and the Java code. So who will compile those intermediate code into the machine code? So this layer does the task. So this is the layer where your Java application is getting compiled into the machine codes. So just about that, there are some core Java libraries which is required for doing so, that is present here itself. So you ignore this. This is a system services which is written in Java, which is provided by this Android framework layer. So this is one of the important layer. Okay, so what is this layer, Android framework layer? This layer provides the Java class which can which will provide the APIs to this application layer. So this application developers, if he want to access this camera device, this Java layer will provide Java APIs which he will use in his application to call this hardware. Okay, so this also has all the system services are coming in this layer. Okay, so this layer is who is developing that. So one important thing is this Java classes, right? It will be running in this app process itself. So whenever I talk about this Java system services, right, there are something called activity manager, which will manage the life cycle of the application, like starting the application, killing the application, resuming the application, pausing the application. And if it comes to power management, like managing the power of the device, there is something called power manager, and managing the window surface, like display, if you want to display something in your application. So there is something called window manager. There is something called content provider, which is like, see, you are having your contacts in phone contacts, but you are using WhatsApp. So your WhatsApp wants to use all this content. So this content provider will provide that content access. Okay, so there are so many managers which is provided, which is present in this layer, that is called system services. So next is the topmost layer, which is application layer. So here we humans are interacting in this layer, that is called human machine interface. So these applications is the way we humans are giving the command, then it will come to this framework layer, then it will come to this Android runtime where it is getting converted into the machine code, then it will come to this HAL layer which will directly talk to this device. Okay, so here in the application layer there are three types of applications in Android. One is third party application, one is privileged application, one is device manufacturer app or system application. Let me come with this third party application. What is this third party application? As the name says, this is developed by some third party. You are either developing it in Android Studio or anywhere else. Here you are not having access to some of the system APIs, like some of the important APIs. Only the application which is having permission can use it, but you can use APIs like camera API, audio API, media API, that you can use here. So next is system API, system application or device manufacturer. These are all the application. This is majorly present in EOS code itself. There is one folder in EOSP source code called packages where you will be developing these applications. So they are having the API access to this, some of the important APIs which cannot be accessed by third party. Like if you are using this Samsung, right? For example, Samsung is developed some. He's having his own secret sensors like proximity or any other sensor. So that APIs, right? Only this app can access, this can't access. Then there is something called privileged app. Privileged apps, in the sense, this is also developed by a third party application developer, but he will be having some permission so that he can use this system APIs. Means he will be having some keys, that key should match with this system API key, then he can use this system API. So that is all about this Android EOS architecture. This is very simple. Okay, so this is common to all the other architecture which are in picture today. Okay, so this is the basic of Android. So in today's video we covered the basic of Android, history of Android. So in the upcoming videos we will be discussing in detail of all these layers. Then we will see some of the important other topics of this USB. So that's it. That is for today. And thank you for watching this video. Please subscribe my channel Coding Guru. Thank you.